This is video 12. And you well remember from video 11, this is how far we got. What we're trying to do is develop an algorithm, a stepwise sequence of instructions that solves the problem of, oh no, my list is out of order. And here's what we got so far. The first stab at it, which is not an algorithm at all, it's just trying to move that direction. We go through the list from front to back, swapping each pair of numbers that are out of order, and we do that over and over again until no swaps occur. This is the sorting algorithm dance. Try it at home, won't you? That'll never do. That's nowhere near Python. Let's refine that. Refined. Aren't we refined? Well, you know what? Let me show you how smart you are in Python. I told you I would. Go through the list from front to back. You know how to do that. How do you go through a list from front to back? Well, it's got to be a loop. And if it's a list, you got to know in advance how long it is. We've seen that. That's a for loop, is it not? For loop. That'll take us through the list from front to back so we can look at each pair of numbers. Now, see, you knew that. You also know this. You know that to swap a pair of numbers that are out of order, how can we explain to the computer, look and see, if that pair of numbers out of order, then swap them. How are you going to do that? You're going to do that with an if statement. We're on a roll. We're going through the list from front to back using a for loop. If a pair of numbers is out of order, we're going to swap them. And then we got this piece down here. Over and over. Over and over. Ah, yes, that must be a loop. Maybe another for loop. Maybe not, though. The reason we got to use a for loop here is because we have to know in advance how long the list is. It's got to be a list of 10 numbers or a list of 12 numbers. No infinite length list is allowed. So we take the whole list and go through from front to back. That's a for loop. Whoops. I'm going to need that. This over and over until no swaps occur. You know what? If the list is already in order, it's only got to go through the list one time. If the list is completely backwards, we got to go through the list a bunch of times. Ooh. So what am I aiming at? What am I driving toward here? Over and over until no swaps occur. We don't know how many times that is. So we don't get to use a for loop. Darn. Let me rephrase this. Let's loop over and over while swaps keep going on. I had one dramatic line and I blew it. Over and over while swaps keep occurring. There we go. While loop. All those pieces. We knew they'd be good for something someday, and here they are. A for loop is going to be in there, a while loop is going to be in there, an if statement is going to be in there. And we might even be able to formulate that as an algorithm, which might even turn into a program. I'm going to see if I can color code it. That's a green if up there, so I can find my green marker. My refinement, I'm going to kind of do it like a Chinese character. Maybe start in the middle and work my way out all different directions. The if stuff, that's like a key part of the whole algorithm, is swapping things that are out of order. So I'm going to start with my if. If this element, ELT, this element, meaning the list element I'm looking at right now. We've seen using lists with for loops. You used that in Project 3. You had a list of hexadecimal colors, and your for loop, the index, controlled which one of those colors you were looking at. If I was 2, you were looking at element number 2. So this element means the one I'm looking at right now because the for loop told me to. The for loop said this is where we are. Okay, I've said enough about that. If this element is greater than next element. Ooh, well, that's not as bad as it sounds. This element is the one we're looking at right now, number I in the for loop. Is greater than the next element. Well, which one is that? That's number I plus 1. So I'm comparing this element, the one that sits at element index I, with the next one, element I plus 1. And when this actually turns into Python code, if that didn't make any sense, then you'll be able to lean back and nod knowingly and say, oh, yeah. I knew that's what he was talking about all the time. What do? Then swap them. Why did I put swap in a box? Well, that's actually going to be a separate little miniature algorithm. How do I swap two things? How do I swap the values of two variables? Maybe we've looked at that, maybe we haven't, I don't know. It's not a big deal, but I don't want to mess up the flow of what's going on in the translation of this into something tighter and closer to Python. So I'll just assume, you know what, I can write that swap procedure thing. I can do that later. I don't have to do that right now. I'll just assume that I'm smart enough that I know how to do it. So I put swap in a box, I black box it and say it exists, I'm going to use it. And you know what? I think that's it for the if. There's our if. If this element's greater than the next element, then swap them. Where does that go? Well, that's for one pair. For one pair of elements as I'm going through the list from front to back. So I'm going to unindent over here. This entire if thing, which I should put a bracket around. I wish I had the courage to just leave these markers open full time. I'm gonna be good. I'm gonna be strong and see if I can do this. And just leave the marker open. Okay. If the element's greater than that goes inside a for loop. For what? For he's a jolly good fellow. For each consecutive SEC each consecutive. I got it. For each consecutive pair of elements in the list, almost ran off the board. For each consecutive pair of elements in that list. That means I'm going to start off by looking at element number 0 and element number 1. That's the first pair. Then I'm going to move it down. Look at element number 1, element number 2. Then move it down again. Element number 2, element number 3. The for loop is going to help me go through and do that with its magic little index number that increases automatically each time through the loop. So each time I go to the next pair, I will hit this green if statement again and decide whether or not I'm going to swap them. And you know what? There's the for loop. The if statement is completely contained inside the for loop. All I need now is a while loop. And I put the cap back on. Old habits die hard. I might need blue again. So I'll leave it open. Refined is now in the way. The while loop. Where's the while loop go? Well, what is it we're doing over and over until no swaps occur? We're going through the entire list over and over until no swaps occur. So working our way out, I told you I would start in the middle and kind of work my way out, and that's why I needed to make room here at the top. Wasn't thinking ahead. While swaps are still occurring. Swaps are still, well, that's not a good way to phrase that. While at least, I like this better. While at least one swap occurred. The board's moving on me. While at least one swap occurred, then I've got to go back and start all over again. Every time I hit this for loop, I'm going through the while loop again. Every time I hit this for loop, it's going to start all over again at the front of the list. And look at each pair. Here we go again. Swap, 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 swap. And if at least one time I had to swap elements that were out of order, oh no! Then I've got to go through one more time, one more time, one more time, one more time, until I can get through the whole thing and no swaps occurred. Only then will I know that my list is in order. Don't trout! Now, what could be simpler? Well, perhaps lots of things. This, we discussed that. This is the current element in the next one. This is a for loop that's going through, and the index number is going to choose which is the current element. This, how on earth are we going to communicate whether or not at least one swap occurred? Hold that thought for a second as I put yet another dark line and hope that I have enough space on the whiteboard. Here's a new idea for us, a new small design pattern. Remember those? Those were the days. Running total, a counter, those kinds of things. A special use of a variable. So special use that it had its very own name. Here's a new one for us. Definition. Flag. A flag variable tells whether or not, W-H-E-T-H-E-R, whether or not some, oh, and by the way, all my definitions are working definitions. You're not going to find it written like this in your book. A flag variable tells whether or not some, and I got to put this in quotes, it was just so far off track terminology-wise. A flag variable tells whether or not some watched for, not watched. Today is bad spelling day. Watched for event ever, E-V-E-R, occurred. That's probably completely nonsensical. Let me put a format or a fig or an illustration or whatever, I'll call it format. Now, remember with our running total, we initialize it to 0, and then we add something to it, typically in a loop. Our counter, we initialize that to 0 and add 1 to it in a loop. A flag doesn't even have that many different possibilities. What we'll do is set flag to false. And then typically in a loop, inside a loop, if event occurs, and by that I mean the event that we're trying to keep an eye out on, were there ever any freezing temperatures? If the temperature is less than 32, then I'm going to set the flag to true. There's an example. If event occurs, O-C-C-U-R-S, set flag to true. I'm afraid I made that sound more complicated than it actually is. Here's the general idea. We start off with the flag at false. All flags are down. Nothing's happened yet. And let's say I am reading a list of temperatures, going through a loop, reading temperatures, maybe even converting them from one temperature system to another. I want to know if any of them were freezing. I don't really care if all of them are freezing, but I do care if at least one freezing temperature. One is as good as a million. If any freezing temperatures occur at all, then I want to know about it. So as I'm reading this list, 100 degrees, wow, that's not freezing. 75, that's pleasant, but that's not freezing. -3, whoa, that's freezing. Raise the flag. I raise it so you can see it on the screen. Raise the flag. Flag is now set to true. Now, once it gets set to true, here's a weird thing about flags. Once it gets set to true, you leave it to true because you want to know whether or not it ever occurred. You don't set it, it doesn't flip back and forth between true and false. You set it to false until that event occurs, and once that event occurs, you raise the flag to true, and then you leave it there. What does that have to do with anything? Let's look back at this. I didn't have a thoughtful enough pause. I'm sorry. What does that have to do with us? Now, let's look at this. While at least one swap has occurred. That is a candidate condition for a flag if ever I've seen one. Our flag used to be set to false before we start looking at the list, before we start going through it. No swaps have occurred yet. They haven't had an opportunity to. If this element is greater than the next element, then we've got to swap them. And you know what? Not only are we going to swap them, we're going to set the flag to true. Yes, at least one swap occurred. And that's enough to make this thing have to go through the whole list again. So here we go again. We set the flag to false. No swaps have occurred yet. If a swap occurs, set the flag to true and leave it. Leave it for how long? Leave it until we go through the entire list, until we completely exhaust the for loop, so that when we come back around the while loop can test and say, you know what, a swap occurred, I'm going to have to make you go through again. It does that over and over until the flag can remain unscathed until we can go from the list front to back without having to switch the flag to true. So somehow or another, I'm going to have to take this multicolor algorithm and weave in a flag variable so that it's something almost Python. It's pseudocode right now, but it's perilously close to Python. We can almost do it right now. But I'm not going to do it right this minute. That'll be something to look forward to in the next video. Until then, see you online.